So we're going to look at factoring by grouping today. And to start off with, we're also going to look at the expanding and distributing first. So in this particular case, we are multiplying a binomial by a binomial, but the variables are different. So if we actually distribute this one out, we would get 3x times y, and we'd have also 3x times negative 4, just for those first two terms. Now I haven't actually multiplied them out, but I can. Another way of looking at what I just did is also saying, well, I have 3x being multiplied by y minus 4. So another way of looking at it. If I was just to distribute this out, I would get 3xy minus 12x for those first two terms. If I look at the next two steps, I have top positive 2 times by y, and I'd have 2 times negative 4. Which again, another way of looking at it is saying it's positive 2 times by y minus 4. And again, if I distribute that out, I'm going to get plus 2y minus 8. Because the x and y's are unlike terms, we actually end up with something that can't be simplified, and we get 4 terms. So that's expanded and simplified. Now let's look at how we can go and work through this backwards. So if we start with 4 terms, and we'll use the same example, we're going to try to look at this format up here and try to convert it into this format. If you notice, it's the first term times by the entire bracket, and the second term times by the entire bracket. So if you actually look at two terms, we can find the greatest common factor of these two terms. Greatest common factor, 3xy and negative 12x, is going to be 3x. When we factor it out, you then get y minus 4. So we're getting to this format that we want up here at the top. If I look at my next two terms, I want to find the greatest common factor again. In this case, it's just 2. And then we'd have y minus 4 inside of our bracket. One of the most important parts of factoring by grouping, which is what we're doing, we're creating two groups that we're looking at, one group, two groups, is that we want to get the exact same thing inside the bracket. Because we're distributing this entire first term, first binomial, to everything in the second binomial, we need to have the exact same binomial in the brackets. As a result, we can then work backwards and say, well, it's going to be 3x times this bracket plus 2 times this bracket. So 3x and 2 will form its own binomial. The y minus 4 is what it's being distributed to get us to our factored form. Here's another example. We have 4 terms, so we're going to create two groups. I'm going to create these two and these two. If I look at the first two and I find my greatest common factor, my greatest common factor for the first two terms is going to be 3x. My greatest common factor for the second two terms is going to be 5. So you're going to have 3x times by something in the bracket, so if I divide through my 9x squared y and I divide it by 3x, you're going to get 3xy. If I take 6x and I divide it by 3x, I'm going to get 2. So I get 3xy plus 2. If I take the greatest common factor of the last two terms, and I take my 15xy and I divide it by 5, I'll get 3xy. And if I take 10 and I divide it by 5, I will get my 2. Again, the key thing that you need to have is the exact same thing in the brackets. Based on distribution, the 3x is getting distributed to that binomial, and the 5 is getting distributed to that binomial. So there's our factored form. Now, if you were given this polynomial, and let's say we actually rearranged it so it's in descending order, 9x squared y plus 15xy plus 6x plus 10. Now I just rearranged the order, but I should get the exact same factors. If I group again, and I'll be creating new groups this time, and I look at these two terms, what's my greatest common factor for these two? Well, in this case, 9 and 15 are both divisible by 3. X squared and x, the lowest degree is x, and the lowest degree is y. If I look at the last two, the greatest common factor in this case is going to be 2. So 3xy will go on the outside. You'll be left with 3x plus 5. And on the second part, you'd have 2 and 3x plus 5. Key thing, same thing in the brackets, which you do. So you can write it as 3xy plus 2 and 3x plus 5. It's exactly the same thing. Multiplication is the same thing if you go 2 times 3 versus 3 times 2. The order doesn't matter. So, as long as you create two groups, and when you factor out the greatest common factor, you get the exact same thing in the brackets, you'll end up with the same factored format. Here's another example. Now we're working with trinomials again. So far we've seen how to factor trinomials that are in the form of 3 terms, obviously, but the key thing is the leading coefficient is 1, meaning that there's a little imaginary 1 right here. So if I look at ones that do not have a leading coefficient of 1, like this example here, we have to kind of approach it in a different manner. We're still going to use our same idea of something's going to add to the middle term and something's going to multiply. But we're actually going to create it so we're going to split it into the 4 terms like we saw in the previous examples. In order to do that, we need to find something that's going to add up to 19, which is our middle term, but it's also going to multiply to not just 15 this time, but 6 times 15. So we have to use our leading coefficient to help us figure out what that's going to be. In this case, 6 times 15 is going to equal to 90. So we need two numbers that are going to multiply to 90 and add up to 19. Well, again, you could look at all the factors. When you look at the factors of 90, one of the most obvious ones is 9 times 10. 9 times 10 is going to give us 90, and it's also going to add up to 19. So we're going to use this to split our middle term and create a 4-term polynomial, even though they have like terms. So by splitting the middle term, we haven't changed the equation at all. All we've done is taken 19x and put it in terms of 9x plus 10x. We've now created 4 terms, so now we can look at grouping. And again, it doesn't matter which way we put the middle terms, we can group them either way, because like I showed in the previous example, once you get your factors, they can be written either way. So if I look at the first 2 terms again and we want to find our greatest common factor, we can see that 3x divides both of those. And if we look at our greatest common factor of the last 2 terms, we can see that 5 divides both of those. So 3x, if I divide that into 6x squared, is going to give me 2x. If I take 9x and divide it by 3x, I'm going to get 3. The greatest common factor of the last 2 terms is 5. If I divide 10x by 5, I'm going to get 2x. If I do 15 divided by 5, I'm going to get 3. Important thing again, same thing in the brackets. If they're not the same, we can't use this factoring technique. So 3x plus 5, 2x plus 3. Again, if you had written your split term, if you had written it in the other way, you would end up with the exact same thing. These two, you'd have your greatest common factor, now is 2x, and these ones here, our greatest common factor is 3. 2x, we'd have 3x plus 5, plus 3, 3x plus 5. Same thing in the brackets, 2x plus 3, 3x plus 5. The order's changed, but they're still factors.